Okay, we're going to continue factoring trinomials. The only thing different about the last video is that this time the number in front of the x squared term, known as the leading coefficient, is not going to be a 1. It's going to be a number other than 1. So it doesn't change really the process for doing this. It just changes the number of possibilities that could work for our solution. Keep in mind, there is only one right answer. There is only one combination that unlocks the lock. And it's going to be our job to find that. It's just that there's more options to try. So I know that the x squared term always ends up in the upper left-hand corner, and the constant always ends up in the lower right-hand corner. And I have to figure out what combinations of numbers I multiply together to get -3 that will help me get that -5x in the middle. And don't panic when you think, well, there is no numbers I can multiply to get -3 that add up to -5. There's a little bit of an extra detail in this. So first off, to get a 2x squared, the only way to multiply and get 2 is to do 2 times 1. So it's going to be 2x times x. Now I need my combinations for a -3. Well, I know that I would multiply a -1 by a +3 and a 1 times a -3 in order to get a -3. And this time it will matter which one I put where, but because I don't know right off the top of my head, I'm just going to try something. So I'm going to try the -1 here and the +3 here, and I'm going to check to see if this works for me. If not, then I'll move them around. So in the upper right-hand corner, I have 2x times -1, which gives me -2x. The lower left-hand corner, I have 3 times x, which gives me a +3x. When I combine those together, I get a +1x. Not the right sign and not the right number. So that tells me that I don't have the right combination. Since I don't have the right number, I know that I don't have the numbers in the right places. So I'm going to move them around, and I'm going to put the -3 here and a +1 here. And let's see what I end up with this time. So in the upper right-hand corner, I have to do 2x times -3. Gives me -6x. Lower left-hand corner, I have to do 1 times x. That gives me a 1x. When I combine those together, I get -5x, exactly what I want in the middle. So now I have my two binomials, one lying along the left, 2x plus 1, and one on top, x minus 3. And those are my factors of 2x squared minus 5x minus 3. Okay, now the next example, 6x squared minus x minus 12. I know my x squared term lands in the upper left. I know my constant goes in the lower right. Here's where we add a few degrees of difficulty here. To multiply together to get 6x squared, I have two combinations. It could be 2x times 3x, or it could be 1x times 6x. I have a tendency to choose the combination where the numbers are closer together. So I'm going to try the 2x and the 3x. If it's not right, it's not a big deal. Then I just go try a different combination. Before I go and try a different combination, though, I want to make sure that I've tried all the possibilities that could work with 2x and 3x. Now, -12, I could have -1 times 12, 1 times -12, 2 times -3, -2 times, no, not 3's, I'm sorry, 2 times -6, -2 times 6, 3 times -4, and -3 times +4. And I'll just go with my same system that I used before, and I'll use the ones that are closer together. So I'll start with -3 here and a +4 here and see what I come up with. In the upper right-hand corner, I've got 2x times -3, which is -6x. In the lower left, I have 3x times 4, which is 12x. And when I combine those two, I get a +6x. Not the -1x that I wanted. So we need to erase, and this is exactly what you'll have to do. You'll have to erase. Now, just because the 3 and the 4 didn't work doesn't mean that they don't work at all. They just don't work in those spots that I had them in. So I'm going to put the 4 along the top and the 3 on the left-hand side and see if that makes a difference. So 2x times negative 4 is going to give me negative 8x, and 3 times 3 gives me a 9x, and when I combine those, I get a positive 1x. This time I have the right number, but I don't have the right sign. So what that tells me, I'm going to keep my numbers where they're at and just change the signs on them. So now I'm going to use positive 4 and negative 3 and see how that affects my final answer. 2x times positive 4 gives me a positive 8x. Negative 3 times 3x gives me a negative 9x. And that is going to make this a negative 1x, exactly what I want it to be in the upper, or when I combine my two numbers on the diagonal. So now I can find my factors along the left-hand side of the box, 2x minus 3, and along the top, 3x plus 4. Okay, third example. 3x squared goes in the upper left-hand corner. My constant of negative 5 goes in the lower right-hand corner. The numbers I multiply to get 3x squared would be 3x times 1x. And you really want to avoid using negatives with your x terms. If you need to include negatives, you're going to want to include them on your constant instead. What are my combinations for multiplying to get a negative 5? I could have a negative 1 times 5 or a 1 times negative 5. I don't know which combination it is right now, so I'm just going to put negative 1 and positive 5, and we'll see how that works for us. In the upper right-hand corner, when I do 3x times negative 1, I'm going to get a negative 3x. In the lower left-hand corner, when I do positive 5x times, or positive 5 times x, I'm going to get a positive 5x. When I combine those two, I get a positive 2x. Unfortunately, I want a positive 14. Now that does not mean that 1 and 5 do not work. It just means that 1 and 5 don't work in those spots. Since I didn't even get a 14 at all, that tells me I need to change the numbers around. So instead of putting the 1 here, I'm going to put the 1 along the left and the 5 along the top. So that's going to change the numbers inside the boxes. So now I have 3x times negative 5, which will give me a negative 15. And 1 times x gives me a positive 1x. And when I combine those, I get negative 14. I want positive 14. So that tells me I got the right number, I just don't have the right signs. Let's change some signs on our numbers. So now I'll have negative 1x, positive 15x, and when I combine those, I will have a positive 14x. So my factors would be 3x minus 1 times x plus 5. Okay, in the fourth example, there's a little bit of a problem because the x squared term has a negative in front of it. You don't want to try to use your factor boxes with negatives on the x squareds. So what we're going to do is we're going to factor out a negative 1. Factoring out basically means we're dividing everything in that trinomial by a negative 1, which is going to change the signs in front of them. So a negative 10x squared becomes positive 10x squared. Positive x becomes negative x, and a positive 3 becomes negative 3. And now I want to concentrate on the numbers that are inside the parentheses. So in the upper left-hand corner, I'm going to put my 10x squared. In the lower right, I'm going to put my negative 3. Numbers that I multiply together to get 10x squared. It could be 2 times 5, or it could be 10 times 1. I'm going to start with the 2x and the 5x. My combinations for negative 3 are the same that they were up here in example number 1. Negative 1 times 3, or 1 times negative 3. And since I don't know for sure which one's going to be, I'm just going to start somewhere. So 2x times negative 1 is going to give me a negative 2x. 5x times 3x gives 15x. And when I combine those, I get a positive 13x. I want a negative 1x. I don't have the right number at all, so that tells me these aren't in the right places. So let's put the 1 here. Oops. 1 here and 3 here. So that's going to change my numbers on the inside. So negative 3 times 2 will be a negative 6x. 5 times 1 will be a 5x. And when I combine those, I get negative 1x. And inside the parentheses, I do have a negative 1x. So now my factors are running along the left and along the top. But I also need to make sure I include this negative 1 out in front. If I don't, there's no way I can be guaranteed to get back to my original problem if I don't put that negative 1 in front. If I were to take these factors and all of my answers and multiply them together, I should get back to my original trinomial every time. And if I don't, then that means my factoring was not correct.